All right, everyone. My apologies. I have not had to do dual screen like this, and it locked me out of recording to start with. So we are ready to go now. I am going to walk through a sample of problems, just like you'll see on the test this week. And we're going to get started here with the first one. We have a linear equation. We're going to solve it by balancing our operations on both sides, adding 4 to each side here. The 7b equals -5. Then we divide 7 on both sides, leaving us with b equals -5/7. All right. Number 2. You may not have heard me through number 1, so let me just recap on number 1 there. Verification that the sound is working now. On number 1, we were solving a linear equation, 7b minus 4 equal -9. Added 4 to both sides, gave us 7b equal -5. Then divided 7 on both sides to give us -5/7 as the result. For number 2, we have 5a plus 6 equals 2a plus 6. There are a couple of different routes one could take with this problem. I am going to start with the variable terms, trying to collect them on one side by subtracting 2a on both sides, giving us 6 on the right-hand side, 3 from combining 5a and -2a, or 5a minus 2a, bring down our 6. Now we have some constants that need to come together. We'll do that by subtracting 6 on both sides. Effectively, the strategy there is to get rid of it on the left. It just so happens that when we do so, it also gets rid of it on the right, but we need something there to hold the place. We'll use a 0. And finally, we're going to divide both sides by 3 here. 0 divided by any number is going to give us 0. Come over here with our solution. A is on the left because we have effectively canceled or divided it on the left, and it equals 0. Video will be made available. It may be that you find I'm going fast throughout this, so you can pick back up on your notes with the video later by fast forwarding if needed. I want to make sure we get through the entire sample of potential problems you might see on the test. So for number 3, let's look at 6y minus 1 equals 2y plus 6. Similar to the last problem, we have variables on both sides and constants on both sides. I would maybe start by subtracting 2y on both sides, leaving you with 4y on the left minus 1 brought down. 2y's go away, and 6 is left over to bring down. Now we have constants that need to be collected to one side. Moving that 1 to the right is the strategy. So by adding it to both sides, we're going to be left with just 4y on the left and 7 on the right. Now we're going to take that and move on to division of both sides, dividing 4 leaves us with y equals 7 over 4. For our fourth problem, we have 5 times the group 6 minus 2y plus 4y equals 6. Since we have a group of items here, it's best to distribute throughout that group. So 5 times 6 and 5 times negative 2y. Let's look at that, what that gives us. 5 times 6 would be 30. 5 times minus 2y can be minus or negative 10y. And then we'll bring everything else down, plus 4y, and then equals 6. We want to look to anything that can be combined as we work on these equations. So those two are like terms. 30 minus 6y equals 6. Negative 10 and 4 combined for negative 6y. Now let's take stock of where we are. Looks like constant on the left and the right, variables on the left. So let's leave those variables on the left and move the constant that's over here by subtracting it on both sides. That'll get rid of it on the left, bring down the 6y, and 6 minus 30 for negative 24. Negative 6y equal negative 24 is where we are at this point, ready to divide. And be sure to bring that negative along with you if it is there before the variable or the y or x. If it's there, like it's negative 6, we're going to divide that whole quantity, negative 6. It divides on the left, and negative 24 divided by negative 6. That's going to leave us with 4, positive 4.
Fred,
Yes.
how, when we see these type of equations, what are they going to be? What's the question going to be? Find the,
Solve
what are
and
these,
check
what type,
so far is the only instruction. Solve and
what's it? Say it one more time.
solve and check.
Solve and check, that's all it says.
Yes.
Okay. But what type of equations are these called?
Phrase and WebAssign, and it's simply solve and check. These are like those you would see from section 1.1. Nothing special, like use the quadratic formula or use factoring or anything of that nature. Just go ahead and solve the equation given.
Perfect. Thank you.
Yeah. another solve and check question. A linear equation, so something like we've seen from section 1.1 again. Notice this is number 5, so we've seen 5 problems now from section 1.1. That's about how many you will see. Let's solve this one. We've got a group. So we need to think about what happens from the distribution throughout that group. It's just a negative sign or a -1. Therefore, we're going to change the signs on all of those items in the group. 6 becomes negative, 8x becomes positive from that distribution. And then we're going to bring down everything else. Now let's see what we might combine. Looks like we have some constants over here on the left-hand side for 2. And then we'll bring down everything else. Now we're in a situation similar to some of those that we saw earlier. So let's move the variable term to the left by subtracting that 4x on both sides, leaving us with 2 plus 4x equals 3, since it goes away on the right. And now let's subtract the 2 from the left-hand side so that we get all of our constants over to the right. That's going to leave us with 4x on the left, the 2's canceled, and 1 on the right. Now we're at the point where we can divide 4 on both sides, leaving us with x equals 1/4. Now we're going to simplify the imaginary number given. So for this one, we have both negative sign outside the square root sign and inside the square root sign. Let's think about what that means as far as the imaginary number part, because it says simplify the imaginary number. This must be an imaginary number. So recall, we can think of that as a -1 times 196. And a -1 makes an I. So we'll take care of that -1 under the square root sign by an I outside. And then all we need to worry about from there is 196. Now, I would suggest at this point, trying out some factors. 196 divide maybe 13 or 16 or 17 or 18, 19. Try to get some idea of what the factors of 196 may be. You might want to start from 2 and go up. Break it down into a tree format if that works best for you. Or you can just look for its highest factor by just going up the numbers 1, 2, 3, 4, 5. And then when we get to 14 on this particular number, we'll find that it divides with 14 to be 14. So 196 is 14 times 14. And that is the surefire route of getting 14 as our square root of 196. Now we can take our I times 14, negative I that is. And then the way that this is conventionally written is with the number before the I. So we'll take -14, place it before the I. There we have our simplified result. like I said, there may be a number of other strategies that you've been practicing in class and on your own, such as breaking that down by dividing two first, and then again and again until you find kind of a pair of factors that you can pull out. Use those strategies, whatever works for you. This is one particular path that you could go on, just dividing until you get to the highest quantity that would divide 196. We'll take a look at some additional complex number simplifications, like those involving fractions in the latter part of the review. The next type of question you might see on the test is to perform all operations on this set of complex numbers, 13 plus 6i minus 15 minus 3i. So we have a couple of different complex numbers that ask us to figure out what is the simplified version of this in a plus bi form. Since this has groups, ask yourself, are any of the signs going to affect the group? And that would be yes, with this negative, it's going to affect everything in that group. So let's write that down. What happens? It becomes minus 15 and plus 3i. So I'm distributing that negative. The first group doesn't have any alteration. It's just an understood positive 13 plus 6i, since there's no sign in front of the group. Now let's look at things that can be combined. 13 minus 15 for negative 2. And positive 6i, positive 3i for 9i. So there we have it in our a plus bi form, as it would ask of us a complex number, negative 2 plus 9i. That would be our answer. No need to go any further there or try to simplify that anymore. We're on number 8 now. A problem of this type. Again, performing all the operations implied here and giving our answer in a plus bi form. So notice the structure of this one is a little bit different since we don't have any plus or minus signs in between these two groups. That means we're going to multiply them together using something like the FOIL strategy. So first outer inner last, our first two terms, 2 times 5 for 10. Outer term, 2 times I for plus 2i. Inner term, negative 4i times 5 for minus or negative 20i. And then our last term, negative 4i times I for minus 4i squared. Then we need to clean this up a little bit to get it into a plus bi form. Let's first look at combining these two. That's going to be minus 18i. 10 coming down, and then recall I squared simplifies to negative 1. So we're going to come in and do minus 4 times negative 1 in the place of I squared. That will give us 10 minus 18i plus 4, since we've got two negatives there, multiplied together, that becomes plus 4, which would then simplify to 10 plus 4 are like terms here. 10 and plus 4 for 14 minus 18i. There we have it in our a plus bi form, 14 minus 18i. phosphorus. That's a definition of something we should remember or maybe have in a note to apply anytime we have an I squared to substitute in -1. With the superscript or up here to I squared. That answer your question? Similar question, perform operations, give your answer in A plus BI form. Don't be tempted to just go at this as given. Write it out for yourself as two groups of 3 minus 4i. And then I'm going to do first, outer, inner, last without the arrows this time. We've got first 3 times 3, outer 3 times -4i, inner -4i times 3, and last -4 times -4 for 16, and both of those have i's on them as well for I times I squared. Combine like terms, these two -12 for -24i, and then again apply our definition of I squared being -1 into this place where we have it on the end, 16 times -1. That gives us 9 minus 24i minus 16, which simplifies with the 9 and the minus 16 to -7 minus 24i. The next, we have perform the operation, giving our answer in A plus BI form again. Notice with this one, we have division of the 6 minus I. And if we recall, how do we handle division of complex numbers? That's by multiplying the conjugate. So the conjugate of this is 6 plus I. Take the opposite sign of the I term to create the conjugate and then multiply it on both the top and the bottom. Think of it as a grouped operation like this. So as we multiply -7 times these terms, we want to think of it like distribution. -7 times 6 gives us -42, and -7 times I gives us -7i over. Now, let's think of these as groups. 6 minus I times 6 plus I, that's a FOIL strategy. So first is 6 times 6. Outer is 6 times I. Inner is -I times 6 for -6i. And last is -I times I for -I squared. Now we want to clean up the bottom of that by combining the like terms that we have here. So that's -42 minus 7i we have on the top. Notice those middle terms from the bottom are going away. They cancel. And we have 36 minus I squared, that's minus -1. We plug in for I squared. And so that's going to become +1. rewriting our top information, and then we have 36 plus 1 here. That's going to give us a 37 on the bottom. I'm going to rewrite what we have on the top in just a moment. We got negative 42 minus 7i over 37. Now to get these in a plus bi form, we need to separate them. Negative 42 over 37 minus 7i over 37. There's our a plus bi form there. Negative 42 over 37 minus 7i over 37. So that is one that is similar to simplifying fractions with complex numbers involved. If you have other questions related to those that involve fractions, maybe write that down, and I'll be happy to look at those later in today's session or afterwards. As far as items like you're going to see on the test, the next one will involve solving quadratic equations such as this. And with this one, we're encouraged to do so by factoring. You're, of course, welcome if factoring doesn't work out for you to try things like the quadratic formula or other methods that is suggested to do this one by factoring. What could we factor here? And x is common to both of those terms, right? Or x times x plus 4 equals 0. Set both of those pieces separately equal to 0. And solve each. So the first one's done for us. We have minus 4 to complete on this second one for x equals negative 4. That leaves us the solution 0 and negative 4. You may see some that suggest you use square root. Like this one has this group squared minus 48 equals 0. It would be best if we want to apply square root to solve this equation to take away 48 so that we get that squared group by itself. (48) is now on the right. We canceled it on the left. And we have 5y plus 2 squared on the left. Let's take the square root of both sides. Remember, that allows us to have the positive or negative result of square root of 48. Don't forget that plus minus. That's what gives you your two solutions. What do we get from the left? The square and the square root effectively cancel one another for 5y plus 2. And we have plus or minus square root of 48 left over here. To start getting y by itself, we can subtract 2 on both sides. Subtract 2. Five y left on the left equals, and this is where it gets kind of weird. Think to your quadratic formula, what that looks like. It's something plus or minus the square root of something. So set it up like that. When you see yourself in this kind of weird set of operations, the -2 is what goes before, then the plus minus, then the square root of 48. So we've got -2 plus or minus square root of 48. There's no way to combine 2 and square root of 48. Treat them like opposite things. Write it out, similar to how you see it in a quadratic formula. Some number plus or minus square root of something. We've got -2 plus or minus square root of 48. And a 5y left over here for us. Now we can divide 5 on both sides. You get y by itself, and then that's going to be a -2 over 5. Now let's talk about 48. Let's just come over to the side here real quick and talk about how does 48 break down? That is 2 times 24. Two times 12. 12 is 2 times 6. And then our 6, running out of room there, that branches off to 2 times 3. Right, so as we collect all of the information, we've got a pair of 2s there, another pair of 2s here, looking back to all of our branches, and then one leftover thing here with the 3. So 2 pairs of 2s gives us 2 times 2, which can come out of that square root, and then that 3, which had no pairs, stays in. Now, final answer, y equals -2 plus or minus 4 square root 3 all over 5. And then if your class is using WebAssign, the software online, you want to make sure that you break that out and say -2 plus 4 square root of 3 over 5, comma, -2 minus 4 square root of 3 over 5 as you enter your result. You can break down 48 in other ways, yes. Whatever way makes most sense to you. Earlier, I did 196 by looking for the pair 14 and 14. In this one, I broke it down into the prime factors or the smaller ones, like 2. You could do 4 and 16. So there are a variety of options. I'm sorry, 3 and 16. All right. For this one, we're not asked to solve an equation. We're just asked to complete the square to make it a perfect square trinomial. So how do we do that? We look to this middle term. And I'm going to come over here to the side. I'm going to first divide that middle term by 2. That gives me 6. Sometimes it'll be a fraction. We just have to leave it. That gives me 6. And then I take that quantity and square it. That gives me 36. And then I'm going to come over here I'm gonna say, okay, the perfect square trinomial is x squared minus 12x plus 36. Regardless of what sign you have here, when creating a perfect square trinomial, this sign here will always need to be positive. And when we factor this, it would have x minus 6 and x minus 6. But if we're just creating the perfect square trinomial, we don't have to worry about what the factors are. We can use the kind of forward-looking know-how about what a perfect square trinomial looks like, what to do with the middle term, to just go right at, okay, that's going to be a plus 36 to make that a perfect square trinomial. And just for your reference, what is that square? It's x minus 6 squared, if we were to factor that. But that's not what's being asked here, just to produce that last term by dividing 12 and then squaring what we get after that. 12 over 2 for 6, 6 squared for 36.